Welcome back to another lesson, where in this one we're looking at electronic structure. Now it's an important topic because it links into drawing atoms, the periodic table and the trends, bonding, both covalent and ionic, isotopes, and lastly drawing ions. Right, let's get started and we'll recap our general structure of an atom, with both protons and neutrons in the nucleus found in the center and electrons orbiting the electron shell. Now, for the purpose of this video, we're only going to be concerned about the electrons and electron shells. So let's have a look at the rules which we'll need to draw them. We'll put the element symbol in the middle. We'll fill up an electron shell before moving on to the next. And then lastly, each shell holds a specific number of electrons, with the first innermost ring holding 2, and then every electron ring after that will hold a maximum of 8 electrons. Let's see this in practice. Here we'll take beryllium as our example, and we can see that beryllium has 4 electrons, and we'll apply the rules which we just spoke about. We'll put the element symbol, draw our first electron ring, and then start adding our electrons. And as we can see here, this one can fit 2 electrons. Now that this is full, we'll draw our next electron ring. Out of the 4 original electrons we had, we only need to add the final 2 electrons onto this shell, just like so. Here's another example. We'll take fluorine for this one, and it's got 9 electrons. So let's start with the element symbol, our electron shell here, which can hold a maximum of 2 electrons, and we'll draw our next ring. Now we've got 7 more to add, but we're going to add it in this particular order, where the first 4 electrons are placed like so, after which we'll start pairing them up, 5, 6, and 7. And here's our full complete electronic configuration of fluorine. Now try get into the habit of doing it like this, because it will make a lot more sense when we look at bonding. Okay, we've looked at 2 examples. Now here's 4 for you to try. Take the next 2 minutes to work through these. And if you finish early, skip ahead. And if you need more time, just pause the video. Here's the answers to those questions. Let's apply this to a past paper question. Take the next minute to work through this, and I'll check back with you. Here's the answers. Right, now this is worth 2 marks. However, depending on your exam board and exam series, each one of these could be worth a maximum of 2 marks. Now that we've looked at electronic configurations, you may be given a particular structure and then asked for its link with the periodic table. And this is what we should be doing. So we've got silicon here, and silicon is in period 3, which means it's going to have 3 electron shells, just like this. It's also in group 4, which means it's going to have 4 outer electrons. So the period tells us how many shells, and the group tells us how many outermost electrons. And after we do this, because we know the rules per shell, we're just going to add as many electrons as we can to every other shell inwards, just like so. And then if we count them up, we'll have 14 electrons in total here. Using those rules, answer these questions here. Take the next minute to do so, and as always, if you finish early, skip ahead, otherwise pause the video. Let's see how we've done. Right, now let's apply what we've looked at in this lesson to a few past paper questions. Here's the first one. Take the next minute to work through this. Here are the answers. We know it has 12 protons because it has 12 electrons. And the number of protons always equal the number of electrons when looking at atoms. Here's our last question. Take the next 30 seconds to work through this. And here are the answers. Okay, so let's summarize what we've looked at in this lesson. Each electron shell will hold a specific number of electrons, the first being 2, and every one after that being 8. And we need to make sure we fill up an electron shell before moving on to the next. That's it for this one. In our next lesson, we're looking at relative atomic mass. I hope you enjoyed, and don't forget to like, comment, and subscribe. If you have any questions, leave them down below, and I'll get back to you.